Hello, my name is Walter Ellsworth, and welcome to Lab 4 Circuits in Physics 2212. The purpose of this lab was to use fundamental principles of energy and current conservation to predict different circuit behaviors and then use the circuit construction kit, the online thing, to simulate circuits in order to test expected versus measured values. The results of this experiment were that the expected values and the observed values were equal, and the greater resistance in the RC circuit meant that greater time for the capacitor to charge and then discharge. The principles used and the models used for this lab, the loop rule was used, which is the potential difference of a round trip path is zero, or is equal to zero, and follows the rules of the conservation of energy, and the node rule, which is current entering a junction of three or more wires, which is when it splits into two, one splits into two or more, will equal the sum of the currents from each junction and follows the rules of the conservation of charge. And Ohm's law, which is the resistance across a usually, this shows the voltage, but it's used to show the resistance across a resistor. And this equation is the capacitor potential difference to the right. Uh, the capacitance of a capacitor that was also used is the equation is shown below. The charge stored for each unit of potential difference is equal to the vacuum permittivity times the area of one plate divided by the separation distance of the plates, D1, D2. And the system was the measuring device, the surroundings were the circuits and the components. This is the RC circuit on the right. This is how it was set up with the ammeters on the left. The details of part A1, the circuit consisted of two 1.5 volt batteries, two ammeters, two resistors, and this was the expected current. This was the measured current. It doesn't go out that far to the to the 10,000th value, so that was the discrepancy. The details of part A2, the expected values were 3 volts. I measured 3 volts. One emitter was replaced with a voltmeter instead. And then for part 3, the potential difference measured across each point, you can see from A to B was 3 volts, from C to D was negative 0.96 volts, and from E to F was negative 2.04 volts. All others were 0 volts. And then, as you can see, it follows the loop rule. The For part A4, an ammeter was placed in parallel with the ohm resistor, the 100 ohm resistor, and measured increases due to the fact that the current was split at the junction. So that meant that the circuit's overall current had to increase once the current avoided the resistor, and then the current didn't recombine. The details of experiment part A5. As you can see, these were the calculated resistances of the resistors, pretty close to their estimated values using Ohm's law. The details of part B1, the circuit with the 9-volt battery and the 200 millifarad capacitor and 10 ohm bulb. Charging time was 11.9 seconds. Discharging time was 12.1 seconds. I mean, it was pretty inaccurate, but the charging time with the 10 ohm bulb was 22.3 seconds. Discharging time was 25.8. Potential difference measured between each points. This was for part B2. The measured differences all added up to zero. I mean, because according to the conservation of energy, A to B was 3 volts, C to D was negative 0.96, E to F was negative 2.04. Added together is zero. This was the graph potential difference versus time for part B2. And using this, I was able to calculate the slope. In calculating the slope, I was able to calculate an RC value of 5.988 seconds. And possible errors were that the calculated experimental was equal, the ammeter didn't go to the 10,000th place, and personal timing with the stopwatch. And the discussion is, what if I was doing this in real life, a real ammeter instead of an ideal simulated one? Well, then uh, it would be different. The real ammeter would have some non-zero resistance, and that would influence the measured current, and it would lower it. And then what if I was to do this lab in real life with a real battery to charge a real capacitor? The ideal model says the capacitor would become fully charged instantly. In real life, the non-zero resistance of the wires and capacitor would increase the charging time. It wouldn't be zero, but it'd be pretty close. Thank you very much.